In this lecture, we want to get familiar with a new type of kinematic joint, known as pin on a slot, where a pin belonging to a rigid body is constrained to move along a slot belonging to another rigid body. We will then have some examples to better understand this type of joint and see how it affects the degrees of freedom in a system. Finally, we will learn how to replace a combination of a revolute and a prismatic joint by a pin on a slot joint and suggest a simplified equivalent system. Let's introduce a pin on a slot joint. Imagine we have a rigid body which has a slot on it, another rigid body which has a pin, and the pin should move in the slot. Among the three relative motions between the two bodies, the rotation is allowed, the translation along the slot is also allowed, but the translation perpendicular to the slot is not allowed. Therefore, this type of joint takes only 1 degree of freedom and permits the 2 other degrees. The name we choose for the number of joints that permit 2 degrees of freedom is J2. This way we can extend our formulation to also include the joints which allow 2 degrees of freedom. So the most complete formulation for the degrees of freedom is 3 times the number of bodies minus 3 times J0, because, for example, a rigid joint that permits 0 degrees of freedom, in fact, takes 3 degrees. Minus 2 times J1, because, for example, a revolute or a prismatic joint that permits 1 degree of freedom takes 2 degrees. Minus 1 times J2, because, for example, a pin on a slot joint that permits 2 degrees of freedom takes 1 degree. As you see in these figures, a slot can be a straight line or a curve. In this example, the slot is on the ground and the pin belongs to a moving body. But in this one, we have the reverse situation, where the pin is on the ground and the slot belongs to a moving body. In these two examples, both the slot and pin belong to moving bodies. We should notice that a pin on a slot joint between two bodies is equivalent to a revolute joint and a prismatic joint between 3 bodies. Imagine we have a rigid body with a slot on it. A slider is free to move along the slot. There is another link pinned to the slider. These two systems are equivalent. Let's investigate that. For simplicity, assume that the bodies having the slots are welded to the ground and do not move. This way, the degrees of freedom for the first system is 3 times 1 body minus 2 times J1, which is 0, minus 1 times J2, which is 1. So the degrees of freedom is 2. For the second system, the degrees of freedom is 3 times 2 moving bodies minus 2 times J1, which is 2, minus 1 times J2, which is 0. Therefore, the degrees of freedom is 2, which demonstrates that the two systems are equivalent in terms of the degrees of freedom. Sometimes we might use this simplification to eliminate the slider and replace a combination of a revolute and a prismatic joint by a single pin on a slot joint. Let's have some examples. We want to determine the degrees of freedom in these systems. which is 3 times the number of bodies, minus 3 times J0, minus 2 times J1, minus J2. For this first example, obviously 2 bodies, 1, 2, 2 revolute joints here and here, and 1 pin on a slot joint here. So the degrees of freedom is 1. In this second example, the degrees of freedom is 3 times 1, 2, 3, 3 bodies, minus 2 times 1, 2, 3, 3 pins, minus 1 times 1, 2, 2 pin on slot joints. So the degrees of freedom is again 1. In this third example, the pin of the yellow link is moving inside the slots of 2 links. The degrees of freedom is 3 times 1, 2, 3, 4, 4 bodies, minus 2 times 1, 2, 3, 4, 4 revolute joints, minus 1 times 2 pin on slot joints, since we have this pin along both this slot and this slot, and the degrees of freedom is 2. In the next example, this long slot is on the ground. The degrees of freedom is 3 times 1, 2, 3, 3 bodies, minus 2 times 2 pins here and here, minus 4 pin on slot joints, 1, 2, 3, 4, and the degrees of freedom is 1. In the next example, we have this scion link double pinned to the ground. Let's this time simply convert it to a rigid joint between the scion body and the ground. This way, the degrees of freedom is 3 times 3 bodies, 1, 2, 3, minus 3 times J0, which we have only 1 here, minus 2 times 1 revolute joint, just here, minus 1 times J2, which we have 1, 2, 3, 3 pin on slot joints. So the degrees of freedom is 1. In this example, we want to simplify and suggest an equivalent system using pin on slot joints. We have 2 sliders moving along a straight path on the ground, and on the other hand, the sliders are pinned to a rigid link. So we can replace each of the sliders with a pin belonging to the rigid link, which is directly moving along a slot on the ground. This way, the degrees of freedom for the original system is 3 times 3 bodies, minus 2 times J1, which is 4, since we have 2 revolute and 2 prismatic joints. So 1 degree of freedom. And for the equivalent system, the degrees of freedom is 3 times just 1 moving body minus J2, which is 2 since we have 2 pin on slot joints. Again, 1 degree of freedom. Also, in this last example, we want to find the equivalent simplified system. First of all, we notice that since the body in gray is double pinned to the ground, it won't be considered as a movable body and is assumed as the extension of the ground. Okay, as you see, we have a slider here moving along a slot while it is also pinned to another body. We can replace it with a pin on a slot joint. Similarly, here we have the same situation and we can replace it by a pin on a slot as well. This way, for the original system, the degrees of freedom is 3 times 3 bodies minus 2 times J1, which is 4, 2 revolute and 2 prismatic. For the equivalent system, the degrees of freedom is 3 times just one body minus J2, which is 2 pin-on slot joints. And in both systems, the degrees of freedom is 1.